देवांश गुड इवनिंग। तुमने नहीं भेजा अभी तक। गुड इवनिंग सरवना। मैंने आज पूछा था। नहीं मिला। टेलीग्राम में तुमने नहीं भेजा है। टेलीग्राम में तुमने नहीं भेजा, क्यों? सरना सेंड द लिंक इन द ग्रुप बेटा। एक बार नोट्स भेजो। ओहो, ग्रुप सेटिंग ऐसा है। ओके, मैं उसको बोलती हूँ चेंज करने के लिए। आई विल टेल हर टू चेंज। ओके, इंस्टाग्राम में देखो। आई एम फाइन प्रशांत। Okay, fine. So we'll start the class. Last class we were talking about in vectors about simple part co-initial vectors, coterminous vectors. Then what are the three characteristics on which a vector will be exactly dependent on? What are the three characteristics on which a vector will be dependent on? Then we started talking about the three characteristics on which a vector is dependent on is support, sense and length. So length is nothing but the magnitude. Support is exactly the line and the sense will be the direction. So these were the starting point we have started the vector with. But today we are going to first understand what is a unit vector. So if somebody will be telling you 5 into 1 will be what? So you will be saying, auntie, what insane word you are talking about? You are saying that 5 into 1 is exactly 5. So what is 1 is about? Then I will say that 1 is unit. Then 1 is unit. Then you will be saying, auntie, what is so unique about that 1? Why you implemented that 1 with 5? Because 5 is exactly the 5 is exactly having a magnitude. Then what is the need of implementation of that 1? Then I said that if 1 is a very special type of vector and this one is called as a unit vector and this one will give direction to 5 and it will make 5 as a vector, then 100% it is a very important point. Now consider my point very nicely. Listen to my point very nicely. What did I said right now? I said that like 5 into 1 I wrote. Fine. So 5 is a number which is exactly taken as a magnitude. Now I took I took 1. So the moment I took 1, just understand 1 by 1, it's a very important point. If you have taken 1 and 1 is exactly giving direction to 5, is it any harm in that? So that 1 is exactly called as unit vector and this unit vector is exactly specified to give direction. So if I know that only one magnitude is present and I cannot give direction to a number, then can I multiply unit vector with that? So the moment I am going to multiply unit vector with that, I will be exactly presenting a vector. Come on, let's see this one out. So apart from definition and all now, let's understand vector in a very different way. So if somebody will be telling me 5 will be exactly, somebody will be telling me 5 is exactly there 5 into 1 is there equal to 5, then it's not a joke for me. I'm not going to take it as a joke. I'm going to present it very nicely. I'm just going to show it one simple thing to you, like you know that definition wise whatever it is said, but I'm going to take it as a vector by magnitude of a is equal to a cap. So this one formula is there. So that means this is a vector. So if I am going to write a vector is equal to a cap into magnitude of a cap into magnitude of a. So now what is exactly this is showing about? Good evening Mahesh. Good evening. Late by 5 minutes. What about you Mahesh? Just think about, you are also late. Today you are also late. But the most important point I am talking about, Mahesh. So I just told Sarvana to multiply. Devansh is also there, I think. So I just told them to multiply 5 with 1. And they are exactly right now multiplying 5 with 1. And then I said one simple thing that if a number 5 is there and I am multiplying 5 with 1, what change it is going to give? Come on, Mahesh. Tell me. If I am going to multiply 5 with 1, what I am going to get? Oh, you are late by 5 minutes. No problem, Mahesh. But a very important point about unit vector I am going to talk about. So only I am just asking this. If somebody will be telling you that 5 is there, 5 is a number. Okay, fine. 5 is a number and 5 I am multiplying with 1. So what I am going to get? What I am going to get? Quickly say. If 5 is a number and 5 is exactly multiplied with 1, what I am going to get? Hey, 5 ones are 5 yaar. Huh? 5. Yes, Mesh, we are going to get exactly 5. So now this is the concept of multiplication of a number with 1 unit number. Okay, unit. So 5 into 1 is 5. But what if, Mahesh, just understand, a magnitude is given to you and it is not having any specific direction. So if magnitude will be multiplied with a unit vector which is giving direction, then modulus means magnitude means modulus or module. So magnitude into unit vector will be exactly equal to what? A vector itself, because unit vector is going to give direction to the vector. Unit vector is going to give direction to the vector. This is exactly a very logical content I am just going to tell you. So next time you see the definition itself and you see the part. So unit vector is exactly, the magnitude of unit vector will always be 1. So unit vector is not going to create a big change in the vector. Rather than that, it is exactly going to give direction to a vector. Rather than that, it is going to give direction to a vector. A very important point I have discussed about. We just remember this point. So what did I said right now? I said that the unit vector is a direction of a vector. A unit vector in the direction of a vector is denoted by a cap. In the direction of a vector. A unit vector in the direction of a vector is denoted by a cap. Fine. So if I want to know that 5 is equal to 5 into 1, then that 1 is exactly the unit vector. Okay. And 5 is the magnitude. So when vector will be specified, then we are exactly going to talk one simple thing that, okay, one unit vector is there. This unit vector when multiplied to a magnitude, then it is exactly going to present a vector. Okay. Satisfied by the concept? Come on, quickly tell me. So that means unit vector can give direction to a vector. Unit vector overall conclusion I have drawn that, say this conclusion I have drawn that if along any vector, if I am going to multiply a vector, so 100% along any vector, if I am going to multiply a vector, I will be just getting the magnitude. So this is the part I am just going to discuss about. So I hope you might have understood the unit vector concept. Quickly say me, understood this part? Understood now? So just understand, simply when somebody will be next time telling you now, just say that, hey, 2 into 1 is 2. So 2 is magnitude, 1 is unit vector. Then 2 into 1, whatever will be coming, it is a vector, because magnitude into direction will be exactly, magnitude with direction is a vector. Fine. So unit vector is direction specific. So it is exactly going to give direction. So whatever vector will come, it will follow the direction of the unit vector. That's it. Simple content. Understood? We'll go back to the next point. So now next concept is parallelogram law of vector addition. So first point I think you have understood. Second point we are going to go for parallelogram law of vector addition. So what does parallelogram law of vector addition means? So if two vectors are there and they are represented in magnitude and direction, so means two vectors are there, the vectors are exactly not a null vector, the vectors are proper vector, they have magnitude also and they have direction also. So I am just repeating my point, two vectors are there, the two vectors are exactly having magnitude and direction also. By two adjacent sides, it is exactly represented of a parallelogram. Then the sum of them is represented by diagonal of the parallelogram. Then the sum of them is represented by the diagonal of the parallelogram, which is coincident with the given vector, which is exactly going to coincide with the given vector. And this concept is exactly going to give the concept of triangle law of vector addition. Triangle law of vector addition. So what is exactly triangle law of vector addition? Just simple concept to understand. My arm is exactly starting from here now. So what I am doing is, I am just saying you one thing, this plus this equal to this, shortcut distance. So what did I said that this plus this equal to this. So arrow goes like this in triangle law of vector addition. This plus this equal to this. So I'm just showing it with the help of my hand. If you will see this part, you will come to know that, so this is A, this is B. So A plus B is equal to resultant A plus B. Okay, A vector A plus B will become A plus B. So you see how the arrows are going in that. The arrows are exactly going like A, my hand like this, arrow, and then the arrow will follow like this, and it is exactly going to return as this one. So this is exactly going to be A vector and B vector, then this will become resultant vector C vector, and C vector will be equal to A vector plus B vector, and C vector will be equal to A vector plus B vector. I remember vector like this only. So if somebody will be telling you, tell me the triangle of vector addition, then I do only one thing. I just say that this part plus this part, this is a part of my hand, and this section plus this section is equal to this section. This is triangle of vector addition. Nothing else I know after this. Okay, so that means, but if somebody will be telling you, okay, if instead of taking this, this and this, now if you are going to take like this, then what happens? If you are going to take like this, then what happens? Then I'll say nothing. It is exactly displacement is 0. So like physics concept and what you called maths concept, I am merging and telling that if initial point and terminal point is exactly going to coincide, then the resultant is coming as 0. Initial and terminal point is going to coincide, then the resultant is 0. Then 100% you are going to ask me that, auntie, how you did like that? So now I'm just going to tell some points of it. Now time by time I'm just going to explain everything along with many questions we are going to do. Fine. So now first thing is, Sarvana, absolutely correct. The resultant will be C vector will be equal to A vector plus B vector. Since we are initiating vectors, so second video I thought that the basic concept should go, and some simple and very good examples, if it will go with you, then you will be able to remember vectors nicely. Okay. So now that means what we are exactly going to do here is, we are taking a parallelogram, and you know that parallelogram, opposite sides are equal, opposite sides are equal, and direction also in parallelogram you have to take specific here. So here arrow C. So what are the marking of the arrows? So first work I am going to do is, I don't know anything, what statement is there, I am just going to follow the statement. Statement says that parallelogram law of vector addition, in that the statement says that two vectors are there, two adjacent, okay, and these vectors are having magnitude and direction. Two vectors are there, these two vectors are having what? These two vectors are having magnitude and direction. These two vectors are having what? These two vectors are having magnitude and direction, and they are exactly the adjacent. So they are represented as, they are the adjacent sides of a parallelogram. Adjacent side means, what is the meaning of adjacent side? In case if you don't know the meaning of adjacent side, this and these two sides are called as adjacent sides. So okay, so vector A and vector B are the adjacent sides of a parallelogram. So if vector A and vector B are the adjacent sides of parallelogram, so now arrow follows like this. Okay, so now vector A and vector B will be written like this. So now one law is there, we already right now discussed about it, but we don't know about it. Fine. So we are exactly going to talk about it, and we are going to say that symbolically, if we want to represent a vector, we can be saying that OP vector OP vector, this is OP vector plus PR vector. OP vector plus PR vector will be equal to OR vector. So this is exactly given in the statement. This is symbolic presentation of this statement. Okay, what is the statement they have given? They said that the sum of the adjacent, you see here, sum is represented by diagonal of the parallelogram. See, the two adjacent sides of a parallelogram, then their sum is represented by diagonals of a parallelogram. So sum. So these two adjacent sides, sum will be equal to the diagonal part. So this diagonal part is represented as C vector. Then C vector will be equal to A vector plus B vector. C vector will be equal to A vector plus B vector. So like this we can say, like this we can say. So now this PR we have to prove. We have to prove exactly this one. So but what we have done here is, the original part is exactly given as this one and this one. So adjacent we are going to take like this, then it will be able to, we will be able to understand in a better way. So now we are going to take this adjacent side and we are going to take this adjacent side. This two adjacent side also we can take, no problem, but here I'm just taking this adjacent side and this adjacent side. So just see that that is exactly a vector and b vector, because the statement says that if two vector a vector and b vector are represented in magnitude and direction by the two adjacent sides of a parallelogram, then their sum is represented. So rather than taking like this, then to directly triangle law will go. So I'm just going to take this one and this one. So what is the sum of a vector plus b vector? So OP vector plus OQ vector, adjacent sides, will be equal to its diagonal OR vector. Okay, so that means this is the concept. It is going to come as a vector plus b vector will be equal to c vector. Fine. So now a vector plus b vector, but we know one very important thing in parallelogram, the opposite sides. The what sides? The opposite sides are exactly having same arrows. You see the direction is same for that. So that means here, since we know that OQ vector will be equal to PR vector. Okay, OQ vector will be equal to PR vector. OQ vector will be equal to PR vector. Very cleverly, what we are going to do is, in this equation 1, we are just going to remove OQ vector and we are going to write it as OP vector plus instead of OQ, because OQ is here and OQ is exactly equal to PR vector because of the properties of parallelogram, because of the properties of parallelogram. Sudarshan, good evening, beta. Okay, so OP vector equal to, God bless you, beta, OP vector equal to PR vector. So now the moment OP vector plus PR vector will come, you see initial and terminal points are coinciding, so it is exactly going to come as OR vector. So we came to know one very specific point here. So if somebody will be asking you, just say this, you just say this point, I follow my arm. Just simple concept, I follow my arm, means this and resultant is coming. This is the shortest distance. Okay, the shortest distance will become the resultant. A vector plus B vector equal to A plus B vector, and this is the resultant, A vector plus B vector, and this is the triangle law. So with this, I think we went towards triangle law. So parallelogram law of vector addition is exactly capable of giving the triangle law of vector addition. That means I just summarize this part and I am just going to give it as a triangle law of vector addition. So what is triangle law of vector addition? If somebody will ask you what is triangle law of vector addition, that what answer you are going to give? What is triangle law of vector addition? Can anybody tell me? Because in school something you might have studied, in physics also you might have studied. Now any concept is there related to triangle law of vector addition? See, basically you are going to apply triangle law of vector addition everywhere. In a position vector also you are going to apply triangle law of vector addition. Only one thing is that position vector means everything you are going to connect with the origin. Everything you are going to connect with the origin. And if you are a beginner and you are starting from the beginning part of vector, then you watch yesterday's video and today you see this part when we are started with unit vector, and now we are going towards small step we are taking. First we understood parallelogram law of vector addition, and from there we derived a very important point, and that is, this is the point. We derived this. We derived this. We derived this. Mahesh, Sudarshan, think about it and say, any one of you think about it and say. Savna, think about it and say, what can be the parallelogram? Head plus tail method. Head plus tail method. Okay, very good. Head plus tail method can be considered as the, can be considered as the triangle law of vector addition. Fine, super. See, everyone is having a way of presentation. I am not saying that your presentation is wrong. That is what. So we must generate. See, there are two ways to study mathematics. One by book, line by line content. One when you generate your own concept. So when you generate, like I generated my own concept, if somebody will be telling me to do this, I am just adding this plus this equal to this. My concept is getting over for triangle law of vector addition. Like this, everyone is having a way of presentation of a vector. So now that means finally we came into a conclusion by seeing parallelogram law of vector addition, and that is, the concept says that, okay, fine, you have a vector like this, A vector, then another vector will be exactly going in this direction, B vector. So arm is exactly coming like this, my arm will bend like this. So the moment my arm will bend like this, now resultant will come this one. So that means arrow will be opposite. arrow will be opposite. Why did I did arrow opposite? From the point. So here one thing is there, if you have to remember about it, then one more thing you can do and you can remember, and that part is, just see here, this is exactly called as co-initial point. Co-initial point. So when in a triangle of vector addition, or whenever you are putting an arrow and you are getting confused that the arrows you have put is correct or wrong, because many times now the students, because when I am correcting the papers now, many a times I am seeing that they will do like this, they will do like this, they will do like this, so they have problem with arrow generation. So see, this is exactly the correct one, this is exactly the correct one, but when they do like this and write everything, this will be exactly called as insane statement, because it is going to give you a 0 1. The resultant will be coming as 0, because from where you started you are exactly going to the same point. So that means the head and the that is what Sarna, what you said, it is exactly going to merge story over from here. So that means this is exactly going to be wrong. So we have to understand that when we are presenting a triangle of vector addition, at that point there will be one co-initial point and one co-terminal point. Just check this one out. This is the point from which two sides are exactly, two vectors are emerging, and here this is the point A. So B, from B point exactly two vectors are emerging, and A point two vectors are meeting. So one co-initial and one co-terminal vector has to be there. So whenever you are drawing, make this point clear that one co-initial, one co-terminal will be there, and then the arrows goes by it like. So you have to just understand that arrows following in a vector is very, very important. Arrows can create a story, arrow can kill a story. Both the points are there in vectors, and vectors are direction specific, and these arrows are playing a very key factor here. So now here, when you will be seeing this part, you see another thing, BC vector plus CA vector. Now another important point, when BC plus CA will be there, it will be equal to BA vector. Simple, basic. Those who are having many problems in vector, you learn this one. See here, just play with this. CC coincides, answer is coming as BA. So just when you are learning and you don't know what to do, kill this one, it is coming as BA vector. For beginners, I am telling, the resultant will be coming what? The resultant will be coming like this. BC plus CA vector will come as BA vector. Now if somebody will be writing like this, PQ vector plus PR vector will be equal to QR vector. Come on, quickly tell me, is this a statement is correct statement or wrong statement? You have to quickly tell me, is this statement a correct one or a wrong one? Whatever presentation right now you are seeing, is this a correct one or a wrong one? PQ plus QPR will be equal to QR. PQ plus PR equal to QR. Is it true or false? Is it true or false? Is it true or false? Just you have to say true or false. Is this one a triangle representing a triangle of vector addition? Is it representing? Very good, Savana. Very good, Savana. It is exactly wrong. How can it be true? Because PQ plus PR is equal to QR. How can it be possible? Here these two are not merging. I told you now, they should merge. They should merge. Means they should be same. So in simple way, they should be same. Okay, they should be same. So they are not at all exactly going to be meeting. So since they are not having the same common, so this is exactly an insane statement. It is not possible. So with this we came to know about, it is correct only mesh. So with this we came to know about exactly it is not possible to present this one. Exactly it is not possible to present this one. So we have understood some points. Now let's see one. We'll go back to the next point. So now here, properties of addition vectors. Properties means I'm not leaving a single point in the vector. If you will be taking these vectors, videos, you will be getting the entire concept. You don't need to go for books and this thing, that thing. No need to rush here and there. Most important questions will come from here. So now look here, properties of addition vectors. So now, see, like when you were studying real number, when you were studying natural number, other numbers, they had a property of presentation. Like when you add two natural number, it will be exactly giving you a natural number. That is called as closure property. So when two numbers like 2 plus 3 you are doing, then 3 plus 2 will come and they both will be same. 2 plus 3 equal to 3 plus 2. Come on, we can understand like this. So vector also follow this rule. So 2 plus 3 equal to 3 plus 2. So exactly it is called as commutative property with respect to addition. Now here 2 into 3 will be equal to 3 into 2. This is called as commutative property with respect to multiplication. So now this logics and these rules are exactly followed. These logics and these rules are exactly followed where? In algebra. Okay, so now we are understanding algebra of vectors. So shall we check that is it going to satisfy commutativity will be followed by two vectors, two exactly proper vectors. So I'm just going to, yesterday itself I said that vectors other than null vectors are called as proper vectors. So today's session will be a bit big and I'm going to explain everything. So vectors other than null vectors will be called as proper vectors. So we are going to take two non-zero vectors. Non-zero vector means proper vector also, you can write like that. So two vectors, take A vector and B vector. So A vector and B vectors are two non-zero vectors. Now we have just presented this in parallelogram. Now in this parallelogram, one small work we are going to do, we are going to join this one. Okay, fine. After joining this one, what we are going to see here is, I hope till here everybody understood. Sarvana, where are they? Where is Vishiga? Where is Harish? Where are the rest of the children? They understood vectors very nicely, na? Very good, super. So now look here. First work is we have to prove commutativity. How to prove commutativity in short? So just go by triangle law of vector addition. So when you are going by triangle law, just you don't need to write total statement also. Just go by triangle law. See the arrows. So if I am going to write by triangle law, we can write in triangle OAB. In triangle OAB, by triangle law, shall we go as OA vector plus AB vector will be equal to OB vector? You will say, yes, auntie, we can go like this. Why? Because you see, A and A are merging. Okay, so now my arm is exactly telling the entire story. So here this and this, so my resultant is exactly coming like this. So arm followed nicely. OA, AB, so A and A is coming same, so OB vector. So OA is coming as A vector, AB is coming as B vector. So OB vector, we will take it as equation 1. Now we are going to take this triangle OC OBC. So in triangle OBC, since resultant arrow is coming in this one, so now I am going to follow the arrow. So if I am going to follow the arrow, how I am going to go? Now check this one very nicely. This is exactly, see here only confusion will come. Whatever, okay, no problem, but they should tell me now, I'll keep the class accordingly. This is not the way now. So now look here. So it is exactly OB and AOC is there. So now you have to understand one very important thing here. Like when we are exactly going with this, so we have exactly arrows. So we are going to follow the arrows. So if you are going to follow the arrow, you just see here, this is exactly the initial point. And this is exactly coming from here and here to terminal point. So definitely it is exactly going to follow the triangle law of vector addition. So how it is exactly going to follow the triangle law of vector addition? In triangle OBC, you just follow the arrow OC plus CB. OC vector, starting from here, arrow went like this, arm. My arm is exactly going like this, so continuous arm has to go. So here OCB, so it is OC plus CB vector. So now C and C will coincide, it will become OB vector. So what is OC? OC is B vector. And what is CB? CB is A vector. And this will be equal to OB vector. This is your equation 2. So from equation 1 and equation 2, what we have generated? From equation 1 and equation 2, we came to know that A vector plus B vector will be equal to B vector plus A vector. Story over. This is exactly called as commutativity with respect to vector addition. Now here we have exactly added two vectors. So that means we came to know one conclusion, that addition of two vector is always commutative. What concept we have generated? Addition of two vector is always commutative. Now Now we have to go towards multiplication of two vectors. So multiplication of two vectors is not going to be commutative. So we are only going to talk about, because vectors are direction specific, so multiplication will not be commutative. So what we are going to do here is, we are going to talk about the next important point. And that is exactly associativity. So associativity is what? Associativity says that when you are going to add three vectors, it is exactly going to follow the associative rule. Okay, only Sarna and Mahesh is there today right now, huh? Now associative rule, let's see about. So first I am going to draw the arrows. So once we are going to present the arrows, A vector, B vector, shall we put arrow like this? So OB vector will be coming. So I just put the arrows. Now, now I'm just going to follow this arrow, and I'm going to just put the resultant arrow like this. Fine. So now A, B and C are here. All the arrows I have exactly put. Mesh. Okay. All the arrows are exactly we have put. Now we have just written one more arrow was left. I put that arrow. So now we are going to go by triangle. So first, shall we go by triangle OAB? So in triangle, we will always follow here triangle law of vector addition. So in triangle, first I am going by triangle OAB. See the arms. OAB. So in this one OAB, if you will be seeing this, you see this OA plus AB will become OB. OA plus AB will become OB. Okay, arm, continuous arm. This is my shoulders and these are my fingers. So OA, AB, so it will become OB. So OA vector plus AB vector will become OB vector. So that means OA is A vector plus B vector will become OB vector. So now OB vector is coming as A vector plus B vector. Okay. So now we are going to talk about this triangle, because now we have A vector plus B vector. Now we need C vector. So now you see, if I am going to take triangle OBC, so in triangle, so this is by triangle law. By triangle law, I have written like this. So now I am going to go by another triangle. Triangle OBC. Now in this triangle, what you are seeing here is, in another triangle OBC. Now see arrows. This plus this will be equal to this. So OC will be coming. So now again you see arm. I am always remembering my arm. So that is OB plus BC. OB vector plus BC vector will be equal to OC vector. Okay. So OB is what? OB is A vector plus B vector and BC is C vector. But arrow, this bracket you remember, and this is coming as OC vector. Take it as equation 1. So A vector plus B vector plus C1, it is exactly going to come as OC vector. So one work we have done. Now we are going to go for the next one. So for the next one, here we came to know that this section is there and this section is there. So but most important thing is, if I will be taking this side, then I am not going to get anything. So shall I start with BC vector? So now you look here, I am going to take this triangle. ABC. So I am just going to write in triangle, again by triangle law of vector addition. In triangle ABC, now you know in triangle ABC, again arm will be followed, AB plus BC, AB vector plus BC vector will be equal to AC vector. So now this time I am having B vector plus C vector will be equal to AC vector. Okay, so B vector plus C vector will be equal to AC vector. So right now first we have this one, now we have B vector plus C vector will be equal to AC vector. Last one, because now we have here this exactly AC vector is coming as B vector plus C vector. We only need to relate it with A vector. So what we are going to do, we will take this triangle OAC. So in triangle OAC, So now only selection of triangle has to be done very precisely. Otherwise you will be able to solve this question. So look here, OAC. Now here OAC, again you follow the arm. OA plus AC, OA vector plus AC vector will be equal to OC vector. Now OA is what? A vector, and AC is B vector plus C vector. Done. Over. And that is coming equal to OC vector. Take it as equation 2. From equation 1 and from equation 2, we got associativity property. The associativity property with respect to addition. Now one more time. Understood everyone? Understood? Sarvana understood? Mahesh understood? Yes. Sarvana, Mahesh understood? Correct only. Understood now? Nothing big you have to do, beta. First we have taken this plus this, you got resultant this one. Then we have taken this triangle. So OC vector came as bracket A vector plus B vector plus C vector. Then we have taken this triangle. See my hand. We have taken ABC triangle. In that triangle, this plus this will be coming as AC. So AC is coming as B vector plus C vector. So once AC is coming as B vector plus C vector. So first we have taken triangle OAB. So that means triangle OAB. So this triangle we have given. So this arrow plus this arrow give this resultant vector, A vector plus B vector. And then we took triangle in triangle OBC. So OBC, that means this part plus this side will become equal to this side, resultant. So here OC is coming as A plus B plus C vector. Then we went by this triangle. Then we went by this ABC. So in this arrow followed this and this, resultant is coming this. So this part is coming as B vector plus C vector. And then we took this triangle, final this triangle. In this arrow followed this and resultant is coming this. So it is exactly coming this one. So by these two equations, we can say that A vector plus B vector in bracket will be equal to A vector plus B vector plus C vector. Vectors are very easy. Some properties and rules were there. Today I discussed the properties and rule. Now look here, existence of identity. What does identity in vector means? So a vector, when it will be exactly added to a null vector, a proper vector added to a null vector will give a proper vector itself. Okay, because null vector addition to a proper vector will be given as a proper vector only. So many a times now, you know what happens, given these type of concepts are coming, we get confused. So one time I'm just discussing this one, how to prove this concept, Now you know that A vector and O vector will be exactly given to you. A vector and 0 vector is exactly the null vector part we have there. So how to present this one? So if somebody will be given A vector, so we will be taking A vector as, so let A vector I am going to write as OA vector. Fine. So now we know that if A vector is coming as OA vector, then finally we need to get A vector. So first part I am taking this one. And A vector is exactly for every vector A vector, and A vector is that vector which is having magnitude and direction both. It is not a null vector. Okay, then the total concept will go in dustbin. So that's why A vector, whatever any type of vector you will take, it should be a proper vector. That vector only will be proving identity existence. Okay, identity existence. So what is exactly A? A is a vector which is having magnitude and direction. When it is added to null vector, then what happens? So since it is added to null vector, how we are going to write A vector? A vector will be written as OA vector. Now how null vector will be written as OA vector, and if I am going to write AA vector, then what will be the resultant? The resultant will be, you see these two are similar, so resultant will become OA vector. And OA vector is nothing but A vector. Story over. Now the second part of it. Second part of it is, we started from this one, A vector plus null vector. Now this time null vector plus A vector. So null vector plus A vector. So when null vector will be everything we are exactly doing with a triangle law vector addition. So here we have used triangle law. Triangle law. So OA plus AA will become OA. Fine. So here also, then here if we are going to apply, then null vector is there. So here null vector part is there, because we know that A vector will be written as OA vector. So null vector will be written as not AA. It will become opposite, negative. You cannot write here like this. You cannot write here like this. This is a wrong statement. If in your brain you are thinking like this, ki why can't auntie write like this? If auntie will write like this, it will become AA vector and its meaning will become null vector only. Okay, so auntie cannot write like this because this is opposite to this one. They have the same magnitude but opposite direction, and this will kill each other and make the vector as null vector. So we cannot write like this. So for this statement we have to take for this side as the we have to take this side. I hope you are understanding this part. So we have to take this side as OO vector plus OA vector. So now these two will coincide. Now the resultant will come as OA vector and it is coming as A vector. I hope you might have understood this point. So this is called as existence of identity. This is existence of identity. Critical, nothing critical in this. Here also triangle law applied. Here also triangle law applied, beta. Shall we go for the next one? Existence of inverse. So what does existence of inverse mean? So if somebody will be telling you what will be the Sarvana understood this point. Now how to prove that existence of inverse? So existence, for understanding or proving existence of inverse, we can do two things. A vector. So if we are going to take A vector as OA vector, A vector as OA vector, then how to prove that existence of inverse? So A vector will be equal to OA vector. So how to write it? So now OA vector will be exactly OA vector plus, this is opposite in direction, magnitude equals to AO vector. So it is exactly OA, AO, this is same. So it will become OO vector and it will come as O vector. So now again minus, so here minus A vector is there. So first I wrote about A vector minus A vector. So now we are going to write about minus A vector plus A vector. So when we are writing like this, it will become AO vector plus OA vector. So now AO vector, OO will coincide, it is coming as AA vector. And you know that AA vector means a vector which is having same initial point and terminal point will become null vector, so it will become O vector. Fine, we have proved another important point. So now we are going to go for the next one, subtraction of a vector. How to exactly subtract a vector and get the subtraction of a vector. For subtracting a vector, we can be taking two vectors like this. So here we are going to take this. So now this will become B vector. This will become A vector. And if arrow will follow like this, then this will become the resultant. Okay, by triangle law vector addition, this will be A vector plus B vector will become A vector plus B vector. Fine. By triangle of addition of vector, A vector plus B vector will become A vector plus B vector resultant. Now, what is exactly AB? AB, if you are going in this direction and you are exactly going opposite of this, so it will become B vector minus A vector. So this part is exactly equal opposite part. So we can write it as minus B vector. Opposite direction means the magnitude wise it will become minus B vector. Magnitude wise it will become B and the part will be exactly minus B vector. So what will be the resultant? Arrow follow the arm, this, so resultant will become like this. So resultant will become A vector plus this part minus B vector. So this section will become A vector minus B vector. This is exactly the subtraction of vector. This is exactly the subtraction of vector. Come on, quickly tell me. Nothing big is here. You have to just apply the simple techniques. So what I have done exactly here in subtraction of vector, I have not applied any rocket science. One simple concept I have used, and that simple concept what I have used here is exactly A vector, B vector is here. Then resultant will become A vector plus B vector. Here A vector is there. Here minus B vector will be there. Then resultant will become A vector minus B vector. Resultant will become A vector minus B vector. I hope you might have understood this point. Come on, quickly tell me. Understood? So I think subtraction part is over. Fine. Shall we go for the next one? Now we are going for some questions. Let's encounter some very beautiful questions. I think this is your first question. Come on, solve this question out. What is your first question given to you is, if P1, P2, P3, P4 are points in a plane or a space and O is the origin of vector, then show that P4 coincides with O vector. Then show that P4 coincides with O vector. No big deal. It is exactly based on triangle law, vector addition and associativity. Then you will be saying, before solving, how can you say this, auntie? I am saying this because of one simple thing. Can you see this point? You have to prove that this will be equal to 0 vector. That means what? If part is exactly added in this. So since if part will be added in this, so since if part we are exactly, Sarvna, understood till here? You have understood? My voice is down. Am I audible? Am I audible, beta? Am I audible? Mahesh. I'm audible or not? Now voice is okay? Feeble. My voice is feeble. Seriously. Sarna, are you also getting the same voice? Feeble? Hey, tell me yes or no. I can't understand that symbols. Tell me it is audible or not. Fine, just tell me it is audible or not. I'm not audible. No, auntie, yes, auntie. What to conclude from this, auntie? Tell me. What to conclude from this, sir? Quickly tell me. Audible. Fine. Now look here. We'll start proving it. It's not at all a very tough question. It's just a playful question. We are only going to play with this question. What is exactly given is P4 coincides with O if this vector, this vector, this vector, this vector will be equal to 0. So finally we have to prove this part. Okay. Okay, no problem, no? Fine, thank you. So now we are exactly going to go with this. We are going to understand this part, how to do this. Very tough question, you know. Now we are going to just write vector plus P1, P2 vector plus P2, P3 vector plus P3, P4 vector. Okay, so now and this part will be equal to 0 vector given to you. Now first what I am going to do is I am going to apply a very tough method. I am just going to keep a bracket here. This is exactly associativity. Associativity with respect to vector addition. Associativity with respect to addition means 2 I have just added 1. So now in that if I am going to add it out, what I am going to get? First, so you see P1 and P1 is going to coincide. So by triangle law of vector addition, this and this is coming same. So resultant will come OP2 by triangle law. Now P2, P3, P4. Good evening, Manish. Now look here. Simple logic here. Just merge this one again. This is by triangle law. So now again P2, P2 same. Initial, terminal, story over. So it is coming as now again triangle law. Again these two same. Hey, we proved it. Done. Yes, Manish, I am having cough and cold. COVID effect. Okay, so just one small thing I have done. So that means P4 coincide with O vector. So once you are getting this one equal to that null vector, so it is exactly telling that P4 coincides with Oh, proved. Yes, Mesh, I also proved. Nothing we have done here. Exactly. First I took associativity. Associativity means I took two vectors common and then I applied triangle law. In triangle law, P1 is same, so it is going to give you OP2. So that is what is triangle law here is OP1, P2. So if this one will be there, resultant will become OP2. Look here, OP1 plus P1, P2 will become OP2. Directly here also again triangle law applied, here again triangle law applied, resultant is coming like that. Medicine लिए medicine का झंडू बाम हो गया बेटा, no medicine affecting. My body is so much medicated. Now look here. Now we are going to go for the next one. PO plus OQ will become QO plus OR. Show that the points PQR are collinear. So first thing is that these type of questions, are they going to exist in front of you? If you are knowing triangle law of vector addition, what next step will be yours? One line questions here. One line. These are exactly not at all question also. So look here, you have to just understand some logic. Yesterday itself I talked about now collinearity definition. So that's what the most important point is. Two vectors are said to be collinear if they have same support or parallel support. Okay, so see, parallel or same. So for collinearity, one small thing will be seen, and if that point you are able to know, you will be able to answer the question with so much ease. Now just understand this point. Now first work what I am doing here is what is the meaning of collinearity? Then you will be saying, auntie, collinear means all the 3 points should be on the same plane, on the same line. I am going to say plane, then it will become coplanar. So P, Q, R. So if somebody will be telling you that same support it is there, I'm not talking about parallel support, I'm just talking about same support. Okay, now same support it is there, and Q is the common point between P and R. That means the three are collinear. The three are what? The three are exactly collinear. Absolutely correct, Sarna. So here also we are going to do the same rocket science. So we are exactly going to write it as OP, because this is same and this is same. So we are exactly going to write as OPQ equal to QR. PQ equal to QR, and then we are going to write a love story there. Ki by triangle law of addition, we have done like this. By triangle law of addition, we have done like this. By triangle law of addition, we have done like this. PQ vector equal to QR vector. Okay, PQ vector will be equal to QR vector, and after that we are going to say that, thus we can say that PQ vector and QR vector can be either collinear, parallel or collinear. PQ and QR can be either collinear or parallel. So both can be possible, but now since Q is the common point, then it will not be parallel, it will be collinear. So there are two possibilities. When two vectors are equal to each other, then that vector can either be collinear, because support and sense and parallel, everything in the first video we have discussed. So again we don't have time to go there and teach you from the beginning. Only one thing is there, same support two vectors can be existing. Okay, so they can be collinear also, they can be parallel also. Okay, so now here this PQ and QR can be collinear also, and it can be parallel also, but since Q is the common point, in simple word we are going to write Q is the common point. So since what is the common point? So since Q is the common point, therefore we can say that PQ vector and QR vector are collinear. So now we are going to talk about the next important point. So here two questions, here one very interesting question is there. This interesting question says that PQ are lying on the same line. Yes, because Q is the common contact point. Here Q is the common contact point. Since it is the common contact point, because of that you can say that it is exactly collinear. Now next one question is there. This question, let's see how you are going to handle this question. They are telling that A vector and B vector are the vector determined by two adjacent sides of a regular hexagon. So we know that what is the meaning of a regular hexagon. Regular hexagon means See, I'm very bad in drawing. I'm sorry. I'm apologizing if I'm unable to draw it nicely. Just give me 1 minute to draw. Okay, just give me 1 minute to draw. I'm very bad in drawing. Regular. Ayyo. Sarna, just 1 minute. Huh? Success, somewhat success, yes. Adjust in this. Don't laugh, don't laugh. It is octagon. 1, 2, 3, 4, 5, 6, 7, 8. Ah, yaar, it is octagon. I have to remove this one. It is not going also. I drew octagon. I told you now I am very good in drawing. So 100% I will be messing something up. Don't laugh, okay? Don't laugh. So I have to draw 6 sides. Hexagon is having 6 sides. Now you have to adjust with this one. Count the number of sides. And don't see my drawing. It is regular. Consider it is regular. Okay. So, sides are not coming equal. But you have to consider. By Khushbu auntie's drawing, you have to consider it is regular. It is regular. Confidence wise. A, B, C, D, E, F. So, I drew octagon. I don't laugh. It is exactly a very good drawing I have done. See, I am so confident of my drawing. So now now look here. A vector and B vector is there. After this, what we are going to do? They are saying that it's a regular hexagon. Now, a very important point for regular hexagon. Before starting, we know that regular hexagon, all sides will be equal. But since it is vector, it is direction specific. So, we have to exactly treat direction very nicely. Everyone remember this one. So here arrows I have to give very, very cleverly. If I will give wrong arrows, means the story will become over only. So now diagonals. Yes. Now I have to find all the vectors taken inside. So all the sides we have to find. So we have to find the magnitudes of the sides. No laughing, okay? No laughing. I am drawing best. My drawing is very best. This is called level of confidence. See, somewhat I drew, yeah. This is the best drawing from my side after so long. So now look here. So this is exactly hexagon. Consider it as a regular hexagon. In question they have given regular hexagon. So you also have to consider it as a regular hexagon. Fine. Don't laugh anyone. So now since it is a regular hexagon, we know that in regular hexagon, the sides will be equal. That is a concept. But one more important thing is this line will always be double of this side. So the diagonal which will be exactly coming parallel to the side, it will be exactly double of it. So you have to just understand, you have to just remember this point that AD vector will be equal to twice of BC vector. This is by theorem. Twice of BC vector. Fine. So AB vector will be equal to twice of BC vector. So first itself AD vector I got. AD vector will be equal to twice of BC vector. Now we will start story because they are asking about all these sides. Okay, we have to find all these sides. So now and regular. So here regular hexagon is there. So first AB vector will be equal to A vector. BC vector will be equal to B vector. So now I am going to apply triangle law of vector addition. So in triangle ABC AB vector plus BC vector, AB vector plus BC vector will be equal to AC vector. So that means A vector plus B vector will be equal to AC vector. Come on. So here AC vector is coming as A vector plus B vector. Now big problem here is we don't know what is CD vector. We have to find CD vector. So again we have to apply, but we know AD vector. Come on, we know AD vector. Right now itself we got AD vector as 2BC vector. 2 B vector. Okay. So now we will apply triangle law in this also. So in triangle ACD, again we will follow arrow AC vector vector plus CD vector will be equal to AD vector. So now AC vector is what? A vector A vector plus B vector. Now CD vector is there, we have to find CD. AD is coming as 2B vector. Shift this one, it will come. Now you are going to get CD vector as 2B vector minus B vector minus A vector. So it is coming as B vector minus A vector. Come on, successfully we got B vector minus A vector. Successfully we got B vector minus A vector for this one. Okay, successfully we got B vector minus A vector here. So now what will be ED vector? Easy. What will be ED vector? See here, AB and ED will be parallel. Okay, and direction is opposite. Parallel and direction is opposite. So if somebody will be asking what is ED, so we will write ED vector will be AB vector opposite na, so it will become minus A vector. Minus A vector. ED vector will be exactly equal to minus A vector. So once ED vector will be coming as minus A vector, now next logic. Nothing is there. It's only tragedy. So this and this is there. So now they are parallel. This arrow follow, they are both are opposite. If this is B vector, opposite sign, so EF vector. So EF vector will be exactly equal to minus B vector. Oh bhai, we have done all. So we got here A vector, B vector minus A vector. This is coming as minus A vector. This is coming as minus B vector. What about AF? Pavam, we have to find this one. So what we have to do for hey, don't see my octagon, huh? I'm going to hide that one. So now look here. In triangle AEF, we are going to take in triangle. Is it coming parallel for something? It is coming parallel for this one. So directly we can write it as A vector minus B vector. But we can find also, na, no problem. In triangle AEF, so what we can do here is we will follow the arrow. So it will come as AE vector plus EF vector will be equal to AF vector, huh? So AE. Hey, we have not find AE. So we have to find AE also. Better than that, we can say now this one is parallel to this one and this one is opposite. That directly it is coming. Why I am doing this much waste of time, huh? Arrows are also same. So here DC vector will be equal to AF vector. So AF vector will also be equal to B vector minus A vector. Story over. Why wasting this much time, huh? They are parallel. Don't see that one. That's not good, huh? So A vector minus FA vector, AF vector. I'm just taking the arrows. I just took the arrows up. Okay. I just took the arrow up. So I'm getting B vector minus A vector. Oh, fine. I'm not merging it. And if you will merge it like this, and if they will give you the diagram where they are just merging the arrows, then it will become 0 vector. Then this part and this part will become opposite. Then FA vector will become A vector minus B vector due to opposite sign. So it is just what arrows they are going to give, with that to do. Don't see my diagram. And this is the supernova question what I was waiting for. This question is exactly coming in. Ayo, time up. What is this, yaar? Time went like this. Huh? Then it will become 0 vector. That's why I just put arrow opposite. Come on, we spend time like anything. Okay, tomorrow we are going to study this 2019 question. Tomorrow we are going to do, and from tomorrow position vector, internal vector, section formula we are going to do. Everything we are going to do tomorrow. And just tell the very intelligent children that be present tomorrow. Okay, 1 hour 4 minutes we studied, huh? Fine. Vector is so interesting, yaar. It's like awesomest topic. Bye bye. Good night.